Oh, I cannot go there. I cannot go there. Introduce.
Welcome to this afternoon's session. Oh, morning session. I'm sorry. Yeah, a different time zone. Next session is about MMIX deployment on the VXLAN, and our instructor speaker today is Miss I mean Hi. Let's give her a round of applause, please. And Miss Kai, all yours.
Good morning, everybody. My name is Damien Kai. You can call me Miss Kai. I'm from Myanmar Internet A team. So actually, I like to share my experience about setting up a VXLAN network for our Internet A team. First of all, I like to introduce about MMIX. MMIX is the first Internet HA in Myanmar. It's a non-profit organization, member-based association. We started operations in September 2017. We started with zero budget, but we got our support from by the communities. Currently, we have 2 IXP, total 3 POPs, and our aggregated traffic is around about 140 gigabit per second. Total connecting ASN is 31 and keep growing. This is our map. We started in Yangon, that is the largest city in Myanmar. We started in September 2017. Recently, in 2023, we can set up another IXP in second largest city, Mandalay. At the same time, we also can give service up to the Naypyidaw, which is the capital of Myanmar. So for Yangon and Mandalay, because these 2 cities are biggest and most of the ISP, they have international gateway there. So we decided to set up a major IXP in Yangon and Mandalay. But Naypyidaw, even Naypyidaw is a capital, there is just a few ISP there. So we decided we'll set up just only a POP, which is the 1 POP of Yangon. This is our existing topology. We have 2 switches in Yangon, in 1 switch in Mandalay. Yangon ISP are connecting these 2 switches, and we have 2 route server. In Mandalay, we have physically 1 server, but virtually we have another server in Mandalay for another server in Yangon for Mandalay route server. Naypyidaw is currently only 1 ISP are connecting. Naypyidaw is just an edge location. This is our future plan. We may set up another POPs in other cities around Myanmar, and in future, we may set up another POP in overseas. That is our future plan. Okay, we'll start network infrastructure, our network infrastructure development. This is our step-by-step. We set up this network by simply, and we develop VXLAN network and step-by-step according to the requirement. So like as the other ISP, at first we have a 1 single switch that is donated by a community. And we also have another server that's also old machine. and we let our ISP connecting to our network, that is simple network. At the same time, we requested content provider, especially CDN provider like Facebook, Google, and Akamai. So after this CDN arrived, we need more network, enhanced network. But this CDN, we have to fill IP transit. So we need a layer 3 device, that means a router. But according to our budget, we decided to use just only layer 3 switch. We deploy layer 3 switch acting as a gateway router. So we are filling IP transit traffic to these CDN boxes. At that time, we used AS number 9654. I highlighted AS number because that information is important for our next slide. At the same time, we can also deploy another physical server so we can get a redundant route server for our network. So then we have a some level budget and we can purchase advanced switches. At that time for the purchasing, we decided to purchase supporting VXLAN and necessary protocols like BGP and OSPF. After we received that switch, we decided to replace existing layer 2 and layer 3 switches with this single new switch. This switch is Cisco Nexus 9K. So for the single switch, we are divided into three routing instance. There is a IPD, we call IPD, that is for IP transit. And another routing instance is DMZ, that is for DMZ. And another is IXP, which is interfacing to the IXP members. The IBD VRF is the main task is to fill IP transit to the CDN boxes. CDN boxes. You may notice there is a two type of CDN boxes, red and color and the green color. Because some CDN, they are connecting directly to the IXP PRN LAN, while some other CDN are trying to stay behind our AS number. So something like the ISP model. So we have to fulfill their requirement for the CDN behind the DMZ, behind our AS number. They need to communicate with the internet for getting IP transit service, and also need to provide traffic to the ISP at our PRA network. So we decided to create a dedicated VRF for this kind of CDN. For the we also create another IXP VRF. It seems DMZ and IXP should be the same, but according to the recommendation, IXP connecting router should not have a default gateway, but DMZ needs default gateway to communicate with international. So we created a dedicated VRF for the IXP PRA. IXP PRA. We stay using the same AS number 9654. For both route server and also international gateway. So we will start VXLAN development, and I will share our experience about the issue we faced. So more and more customers are joining. So we need more ports. We purchased more switch, and we integrated another switch to existing switch. Now we have two switch. So we set up VXLAN. VXLAN, at the time, we are using the same AS number 9654 for all devices, including route server and also infrastructure switches, VXLAN internet switches, the same AS number. So we have to use IBGP feature. We set up IBGP. After that, we noticed one major problem. So because of IBGP feature, prefix received by IXP VRF from connected route server are not passing to another switch. Another switch. So that will be a big problem. So we decided, I tried to find out to solve this kind of problem. So finally, I have to decided to change eBGP between route server and our core infrastructure. If not, it's very difficult to fix this kind of problem. So we decided to change like that. We use another AS number 137.955. It is for the EVVN network, for the core network. At the same time, we keep existing AS number 9654 for the route servers. It's a very easy to say changing eBGP, but in reality, I have to negotiate all the downstream, all the upstream, and the balance of upstream for changing this AS number. So it's taking more than 1 month for these changes. So after we change this stage, I noticed another problem. So for the redundancy, I have two physical server running route server at each physical machine. These physical machines are connecting to each VXLAN switch. So when one server disconnected from the network, we notice uh, we notice ISP connecting to the failed route server network, route server switch network. It cannot communicate to the DMZ network of the remote switch. In this case, let's say left hand switch is a switch 1, right hand switch is a switch 2. So DMZ network, when trying to communicate with ISP on the left side, when packet arrive to the switch 2, it will notice the information of the ISP with the next hop information with then PRA IP address. This ISP connecting to the switch 2 also get prefix information of other ISP, including MMIX, code network DMZ prefixes from route server 2, because route server 1 is already failed. And also, one packet arrived to the right side of the switch 1 packet from the CDN. Packet arrived to the switch 1. Next of it pointing to the PRIB address of the ISP. That PRIB address is pointing to the switch 1 interface. So switch 1 loopback IP address according to the VXLAN network. When packet arrived to the switch 1, one find out the prefix information of the ISP directly connected with them. Actually, it should be go directly to that ISP, but in reality, it's pointing back to the switch 2, because this routing information is getting from the route server 2, not route server 1. So it's starting packet looping between these two switches. So let's find out more about DTM. So routing table of switch 2, this 103.13 or 32.0 is the intending destination of the ISP prefixes connecting to the switch 1, left side switch 1. So its next hop is pointing to its PRN address 102.116.194.12. That address is pointing back to the switch 1 IP address 10.0.1.1. When packet arrived to the switch 1, when checking the from the route server 2, not route server 1. Route server 1 is already filled. So it's looping is happening between these two switches. So we cannot communicate it each other. Members, connecting the all connecting members. and also use dedicated router for DMZ. We cannot use combine. But that problem is happening between the DMZ behind our core network. This kind of problem is no more problem between ISP to ISP. PRN partner is going traffic going each other is okay. This problem is just only behind the server of our network. So I will also share another case. After we decided to set up another internet exchange in the second largest city, Mandalay, we deploy another switch. We set up long distance link, so our connectivity will be like triangle. At that time, we are keep using AS number 137.955, and we used IPTV each other. So it seems everything will be okay. All routes are working. But as per the previous problem, I get some advice from the Cisco team to solve this kind of problem. At that time, I got advice to set up multi-site design. Multi-site design means it should be EBTB between cities. So I studied EBTB. I have to plan to change my network topology used to be EBTB. So we need more AS number. This is only another city. And what if I will set up more and more switches at the other cities? So using applying a public public AS number is not scalable. So now finally I decided to use a private AS number. So for the Yangon, I defined private AS number 65010. For Mandalay, private AS number 65020. At the same time, I use local AS feature to communicate with outside PTV session. So after that, I noticed another problem, that is the import-export problem. So I will explain more detail in the next session for this kind of problem. So I will share another issue. One multi-site configuration, multi-site need should be the IBGB within a city and EBGB between city to city. So it needs a tracking system, fabric tracking and DCI tracking. DCI tracking is for WAN. Fabric tracking is within a city. So every participating router, especially what they call the Bora gateway router, this tracking interface must be active. If it is not, it will not work. In this diagram, we can do tracking for the Yangon network. We have a link between two switches, switch 1 and switch 2. And so we can point the interlink switch as a fabric tracking. But for Mandalay, I don't have any link because Mandalay is only one switch. So I didn't configure, so my network didn't work. So finally, I get advice and I get knowledge, but fabric tracking must be active. So finally, I have to choose one active interface and using tracking on that interface. That is my experience I'm sharing. So let's go for the VRF issue. We are using multi-web VRF. We are using 3 VRF, IXP VRF, and MPD VRF, and DMC VRF. You may notice 3-4 router here. DMC need to route over both IMPD and also IXP. IMPD and IXP do not need to be reachable each other. We made separate for the route according to the routing security. So I defined it a route distinct each ID for IXP ID number 1, IMPD ID is 2, DMC is 3. So when we use a route import export, I exported I exported my own IB of the respective VRF and importing related the VRF. In this case, IXP and IBD, I imported a DMZ ID number 3. For the DMZ, imported ID of IXP and IBD because DMZ is command need to get every information and have to share its information. In reality, I highlighted here with yellow color. In my real configuration, I am using route export map because DMZ do not need international routes, just need default gateway. So for the simplicity, in this presentation, I just show route target export line. In reality, I'm using export map. Not to confuse, I'm just showing the simple configuration. After we set up another node, so on the first configuration, I export own ID, but after connect another switch, I also need to import my own ID. For the IXP, I need to export my own ID number 1 and need to import own ID number 1. If not, the right side switch will not get the information from the left side switch or even in the same VRF. So any other configuration will be the same. Because of the VXLAN, I need to create, you may notice EVVN keyword. These keywords are essential for the router information, carrying VXLAN traffic from the remote switch. So, for the city to city with EPGP. So this is a major find out after I set up major problem and I have to solve after I set up EPGP. Before EPGP, or IPGP, we didn't notice this kind of problem. After EPGP, I noticed this problem because of the EPGP feature. With IPGP, prefix information getting from the another VRF will not pass to the other next same VRF. Actually, I like to let me show you. Sorry. You say here. Oh, sorry, I cannot use pen. You see, here we have IXP VRF will export prefix information to DMZ. DMZ, this information will not pass to the another DMZ because of the IPTV, but it is passing this information to this DMZ because of EBGB feature. So I don't like to pass those information to another switch, even it is the same VRF, because you see this IXP VRF, it has a Yangon PRing members information. It has a prefix of Yangon PRing information. It has to export to the DMZ because DMZ and IXP need to routable. But this information is passing to the DMZ and this information is passing to the DMZ. This DMZ is getting a Yangon IXP information, and this DMZ is export to the Mandalay IXP VRF. That is not my requirement. Mandalay router, Mandalay information, PR information should not be routable each other with Yangon ISP. So finally, I have to decide to use community value to filter the route export. So I use the community value 65001 and attach to the interface of the PRN network. And I prior to the expo round map. Expo round map. So expo round map filter all the filter prefixes, and only desired prefixes are exporting to the another. So you may notice I am using export map for the every VRF. So I filter out. At that time, I noticed another problem. In VXLAN network, STAR32 prefixes are very important. It's the reachable information for the remote switch. I lost all /32 prefixes because of filtering system. If I don't have a filtering system, EVVN keyword will import /32 information. Let's go to the next slide. So if you find out a routing table for this /32, you will notice /32 information of remote switch. So that is the information that we need to go into the remote switch for the PRN LAN. PRN, you may notice this is information of PE1. You may notice 10.1.1.2, 10.1.1.3, those are the remote switches. Normally, simple EVM keyword will work. It will be input OSLA32 information, but after filtering, that configuration doesn't work. So I find out how to solve this problem, and I found that extended community value is using this value. This value is AS number plus VNI value. So I have to explicitly import this value for every VLAN. So if not, it will not work. That is my find out information that I am sharing all of you. So I share my experience about the difficulties during my developing. So I will share about the VXLAN configuration, and this VXLAN configuration is just for the beginners who try to set up VXLAN network. Let's start it. So VXLAN is a virtual extensible LAN and provides a way to extend layer 2 network across the layer 3 infrastructure using MAC in UDP encapsulation internally. Its components are important components are VDEP, VNID, and NVE. VDEP is a VXLAN turner point where VXLAN encapsulation and decapsulation is done, basically a router or switch. In this case, I have 3 routers, I have 3 VDEP. VNID, VXLAN network identifier, which is 24-bit segment that identifies the broadcast domain. And V is the network interface, virtual interface logically created on VDEP device. When I try to land a VXLAN, a lot of documentation keeps saying spine and leaf. They need at least four router or 4 switches to use load balancing, and so I'm quite confused. So that is, I am sharing my learning. There's a 2 layer, spy layer and leaf layer. They are keep same. Leaf layer is for the host and other devices connecting directly. But for my cases, I cannot use dedicated devices just only for the spy. I need to save many. All devices must be usable, all interface must be usable. So in my cases, I decided all devices must be leaf. But I need to find out what is the spy function. So according to the documentation, VXLAN segments are independent of underlying physical network topology. So as long as NVE loopback interfaces are reachable and able to turn on all necessary features, VXLAN is working. You can forget about a spy and leaf for a while. When I find out what is the different configuration between spy and leaf, is it just a reading route target or under the address family L2VV and EVVM? Because a spy may not have the VRF information, but the spine is just a transport layer. So we need to carry VRF information. So you need to configure reading route target or configuration. So for my testing, I'm using Nessus virtual image on the emulator environment. So I'm sharing this configuration for your testing. For need to configure DCAM value. That is for this virtual image. For your real configuration, it depends on your switch model. For my switch existing switch, I don't need to configure this two line. So the MDU value must be increased, but most of the switches is a default. You need to find out, and you need to turn on features, necessary features here. So at first, you need to define three interface, three loopback interfaces. First loopback is for the routing platform. Second loopback is for the NV interface. Third interface is for the multi-site. For the first and second interfaces, loopback interfaces, it must be unique for every devices. I have three switch, so I need three loopback interface. For the third interface, that is for the site. So it's a unique, it must be unique for each site. So I have only two sites, Yangon and Mandalay. I need two loopback interface. For switch previous diagram in switch 1 and switch 2, we'll use the same IP address for the loopback, and switch 3 will be used another loopback interface. So we will go to the underlay network configuration. VXLAN segment independent of underlay physical network topology, as I said previously. And I have set up IEI model. IEI model is within the city. It should be IBTB. IBTB, and city to city, it must be EBTB. I using this model. So I create routing protocol. This is the single city, Yangon city. I create a IGB routing protocol and the routing protocol. I use our OSPF, and over that I set up IBGB. OSPF is just for the loopback information route over each other. In my case, that I have only two switches. The OSPF is actually not necessary. I can directly set up IBGB each other, but for future growth, I start set up OSPF between two switches. And that is depends on your configuration. For the Mandalay, I only have one switches. That's why I don't need to configure IBGB for Mandalay. So I configure EBGB between city to city. This Yangon switch 1 and Mandalay switch 1, Yangon switch 2 and Mandalay switch 1. And MTU value all the interface. At all the interface, you must increase ITU value. If not, VXLAN will not work. So these are the interface configuration for the router 1. Loopback interface, I turn on OSPF routing protocol as an underlay. And also Ethernet 00, which is the intra-city link, also turn on OSPF routing protocol. So all loopback interface must be routed with each other. For the intercity link Ethernet 01, and I didn't turn on OSPF, but increase MTU value. MTU value must be increased on the all physical interface. That is important. This is underlay BTB configuration. You may all have experience about the routing, so this is the same configuration for the BTB routing. So I need to advertise all the loopback address here. In the Cisco documentation, it used route redistribution, OSPF, and then the OSPF route redistribute to the BGP, including interface, link interface. But of my understanding, this link interface do not need to be routed over to the network. Loopback interface is routed over is the most important. This is enough. So I use just simply network keyword to advertise loopback interface. Maximum parts in configurations for to use multiple link that I'm using. So I created the EBGB PR group information that is just only attending on address family IPv4 unicast, and they need to send community each other. For the IPGB, I use update source loopback 0, that is same practice of the existing network. And the important is next hop serve because of the IPGB. So I turn on the IPGB between router 1 and router 2. And this router and the Mendeley router, I turn on EPGB feature. So I will go to the next slide for the overlay configuration. Overlay configuration EVVN, we will set up EVVN address family. It is building of the control plane and fixed antennas to advertise MAC address reachability. And the lay is IP address, loopback IP address reachability. Overlay is MAC address reachability. There is a two method for set up the overlay network, multicast-based control plane and MBGB EVVN control plane. In my case, I used MBGB EVVN control plane. Segmentation of layer 2 and layer 3 traffic. Traffic segmentation is achieved by using VXLAN encapsulation, where VNI acts as a segment identifier. I'm mentioning VNI. It is very important for the VXLAN network. So this is a configuration for VXLAN configuration. Normally VXLAN configuration, most people are using to extend the layer 2 network. In my cases, I'm also have a layer 3, so I'm sharing my configuration. For the layer 2, you need to set up a VLAN and bind to VNI value. We are using VN segment and VNI value here. Under the interface NVE, for the specific VLAN, you need to configure member VNI and VNI value. Under the interface NVE, you must configure source interface loopback WAN. For the routing protocol, you may notice using loopback 0. This loopback 1 is for the dedicated for the NVE interface. So please use different loopback interface. For the multi-site, this device is multi-site border gateway device. If this device is border gateway, you need to configure and interface use loopback 2. That loopback interface IP address must be unique for each site. I use Cypress ARP, multi-site ingress replication, because I'm using multicast ingress replication protocol. I use BGP. Because of layer 2, you need to create one instance under the EVVN. So using the VNI value, saying L2, and I use route distinguisher auto, route target import export auto. That is a recommended one. If we use auto value, it assigns automatically route target value with AS number and VNI value. For the layer 3, you need to configure, you need to assign one VLAN for each VRF. In this case, I use for the VRF IPT, I create VLAN value 1012 and assign VNI value 91012. All the configuration, all the necessary configuration is member VNI 91012 to associate VRF under the interface NVE1. That's all. But you need to bind the VNI value to the VRF context. That is necessary information. And under the address family IPv4 unicast, you can create route target auto EVVN, these two lines. That is a simple configuration I'm sharing. If you are not doing route target import export between VRF, this configuration is enough. using auto value, configuration will be very simple. It will assign automatically ASN and VNI value. So EVVN keyword is also necessary for configuration. So there is an Anycast gateway feature. Distributed Anycast gateway feature for EVVN VXLAN is a default gateway addressing mechanism that enables the use of the same gateway IP address across all the leaf switches that are part of the VXLAN network. In my configuration, I have two switches in Django. All the ISP are some ISP are connecting to the switch 1, some other ISP are connecting to switch 2. For talking with MMIX network, going to the DMZ, the CDM behind the DMZ, they all need to communicate with a single IP address. That single IP address, I am using Anycast feature. Anycast feature, we need to configure fabric forwarding Anycast gateway MAC address here for each VLAN who VXLAN VLAN who intended talking to the other clients. You need to configure under the interface VLAN fabric forwarding mode Anycast gateway, and that's all. So you can get Anycast routing feature. Overlay PTB configuration. That is overlay PTB configuration. Overlays is mainly for the address family L2 VVN, EVVN. I created template EVVN. This EVVN template is for the eBTB network. It's between the Yangon switch and the Mandalay switch. This for the eBTB session. So anyway, even is though EVGB, you need to communicate with the loopback address. That advertised by the underlay BGP network. So because of loopback, we are using loopback, not interface. We need to configure eBGP multi-hop value. You need to turn on address family L2 VVN, need to send community value, standard or also extended. It's for the eBGP you need to configure next hop and change. Because this router is acting like a spy for these two router. Normally it will be okay, but if you are losing connectivity between switch 1 and switch 2, you cannot go through Mandalay if you didn't configure next hop and change. It cannot reach to the another router. But in reality, in my cases, the long distance link capacity is very small. I have 200G between these two switches. Yangon and Mandalay is just only 10G. Even the I lost communication between communication intra-city link. My all traffic cannot carry through this long distance link. But even though I configure this configuration to be safe side. Here, rewrite EVN RDASN. That is important configuration if you are using auto value for the VNI and route target information. If this configuration is doing, let's say the prefix is tagged to the using AS VNI value is using a combination of AS number and the VNI tag. When RD value arrive to the another city, it change automatic to the designated AS value. Let's say when a packet is here, its value is extended community value will be 650.100.10 and VNI value. When arrive to the Mandalay, it will change automatically to the 650.20 and VNI value. This line is doing that. Without that line, you cannot communicate each other. For the IPTV, it just simply turn on the layer 2 VVN EVN address family and send both community value. That is all configuration for the overlay PTP configuration. Multi-site configuration. Multi-site configuration, you need EVVM multi-site Bora gateway number. For the Yangon, both switch 1 and switch 2, you must use the same number that I configure here, number 1. When a switch 2 configuration must be used the same number. For the manually, it should be another number. In my case, I will use gateway 2. For the interface configuration, you need to buy tracking information. For Ethernet 00, it is an interlink between within the city. So you must configure EVVM multi-site fabric tracking. For the WAN link, Ethernet 01, you need to configure EVVM multi-site TCN tracking. So I explained this fabric tracking problem in the previous slide. I also share another problem. So these all router are acting like a Bora gateway router. Bora gateway router for the external BGP config connectivity, like I have international connecting to the international gateway connectivity with the upstream provider. This connection must be due with a Bora gateway router. So in my cases, at first, we don't have a triangle communication. We have only link Yangon WAN and Mandalay WAN. At that time, I noticed we have another external BGP configuration connectivity with another router here. This IP prefix arrived to the Yangon router here. Switch to here. This information is not advertising to the other external BGP session. So I didn't know what's happening. Actually, at that time, this switch 2 is losing its role as a gateway router because it does there is no active interface tracking to the DCI for the WAN link. So in that kind of case, you also need to do the same like this problem. You need to find out when active interface for binding for the tracking. If not, it will not, you will face some unseen problem. So under the router, under the NV interface, you must configure multi-site Bora gateway interface, and under the VNI specific VLAN, you need to configure multi-site ingress replication. Another BGP configuration, fabric peer type fabric external configuration is required. So because all the devices are Cisco, I'm using multi-site configuration as per the recommendation, but some other my friends are saying if I am using a multi-vendor, multi-site will not work. I'm not sure. I have to find out more. Regarding the previous VRF issue, when I tested with the Arista switch, it's more easier because Arista is not using BGP for route input export. It is used by the route channel or something like that. So it's more easy for my case. This is a final BGP configuration. I combine all the previous feature, and you can refer this configuration. The show command show result here. You can find out your result. This is a SAM show command. Show NVE peers. This peer must be up. If not, it will not work. And ingress replication you can find out. And also, I often check this information. Show BGP, do VVN, EVVN summary, so you can find out it's working or not. Another interesting show command is show BGP L2 VVM. So I have a very long list, but I specifically copy the necessary one. So this is for the first paragraph. It is for the layer 2 VNI. This is for the VLAN 20 for my cases, or the Mandalay PRN LAN. So this information is found out from the Yangon network. Our Mandalay PRN LAN is extending to the Yangon. Yangon. So Yangon route can check all the informations here. For the MAC address, is pointing out to the another switch and another switch. This is this own switch, own IP address. 1.1.1.3 is Mandalay switch. 10.1.1.2 is Yangon second switch. So this is the PRN IP address of the Mandalay. Mandalay is pointing to the switch 2, but because Mandalay network extending to the Yangon, and this is the route server IP address existing at the Mandalay network. That's why I'm pointing to the 1.1.3. This is the locally existing IP address. This client is locally existing. For the layer 3 MAC address is pointing to the another switch and the Mandalay switch, and also its own switches based on the MAC address and IP addresses. So the last one, it is our peering client IP addresses. So you can see multiple hop, BGP hop here. So finally, I like to share MMI's current network. This is our network topology. I draw it as simple as possible to you understand. We have two switches. This router is just a VRF inside this switch. It's talking eBGP with other transit providers. So this router can fill traffic to the CDN and at Yango. So mainly is also the same, just mainly we have only one switch and filling the IP transit traffic to the CDN. And for the Nibiru, we have only one service provider. So it's like a remote small switch, small network. So when I set up Mendeley network, Mendeley IXP, Mendeley do not have any content. So no one will interest to connect MMIX Mendeley. So I extend Mendeley network, Mendeley BI network to the Yangon, and I requested content providers to create another link to the our switch. Actually, in reality, it's just a same physical link, but multiple VLAN. So Mendeley user can get content from the Yangon. At the same time, we requested content provider providing more devices in Mendeley. So when the CDN device is hosted at the Mendeley, so Mendeley user, they can get all the same like a Yangon user, some traffic getting locally and some traffic are getting from the Yangon. Even a route server, we have only one physical machine in Mendeley. At the same time, we are using second route Mendeley route server. We host it in Yangon, so we have a redundancy. Red line are for the Mendeley peering LAN, green line are for the Yangon peering LAN in my case. This is a logical diagram for the explaining for the my VXLAN how extending. I extended my management VLAN. I call OM. So we use the same VLAN to manage all the devices extended to up to manually extending all the devices. So here is a DMZ, Yangon DMZ. There is a two Yangon DMZ. One DMZ is just a private address. Another DMZ is a directly public address. It is the same for Mandalay. So PRN network, Yangon is existing only the Yangon, not extending to the Mandalay because Yangon user do not need to get any content from the Mandalay. But for the Mandalay, they need some content from Yangon, so I extended up to the Yangon. Also need to communicate to the route server existing at the Yangon. So that is my finance configuration that I am sharing. So that's all I'm sharing to you all. So for your information, I am not expert in VXLAN. I'm targeted learning for my requirements. So I do not know every feature of VXLAN. But if you like to know about my presentation, I like to share. Your question is welcome.
Do we have any questions?
Hi, thanks for the presentation, but probably I don't really have any understanding about the MMIX network in depth as you do. But my question, why do you need to have a VRF running in between your switches? Because in my perception, internet exchange is like pure layer 2 domain, right? So why there is a need to run in VRF?
Because we need international gateway router to fill CDN boxes. But at that time, I don't like to use another devices to save money and the costing. So I use the same devices, not only layer 2, but also layer 3. That's why I created a VRF.
Okay, so it's like a mix of a layer 3 routing and layer 2.
Yes,
Okay, well, that's clear. That's
to
clear.
save money.
Yeah, that's that. I mean, that's my perception as well. I just
Yeah.
need to have a confirmation. Right. Thank you.
Okay.
Nasrul from Malaysia. Is there any significant advantage of VXLAN that you on how you manage members VLANs or VNI comparing to previous technology that you use?
I decided to use VXLAN, but because VXLAN is more resilient and most people keep saying using VXLAN is good, that's why I try it because I extended my network to the long away city. So that's why I decided to use VXLAN. That's all.
Just one question. Why did you use Cisco, not the other vendors like Arista or whatever?
Yes, when we decided to purchase new equipment, we called multi-vendor. At that time, Cisco, Arista, and also Juniper, they competed, but Cisco get a good price. That's why.
Okay, thank you.
Hello, Oswald from Mongolia. Welcome. After your VXLAN deployment, any broadcast or unicast non-multicast traffic are decreasing?
I hope decreasing, but I didn't know how to find out, honestly.
Okay, thank you.
Now, are you using any kind of like the physical airport security, like any kind of sort of filtering or anything on the customer port?
We restricted total numbers of MAC address at the port. So till now, just simple one. So we may need to enhance our configuration. Thank you.
And another question that when you're considering like various platforms like Nokia or Cisco or Arista, did you consider any kind of like a TCAM profile, like tertiary memory profile per port or shared buffer memory kind of thing? So to hold the like traffic per port, did you consider any sort of like shared buffer per port memory?
I don't know.
Okay,
where-
no worries. Thank you.
If there are no questions, let's give a hand to Miss Kai. Thank you, Miss Kai. The next session will be in 2:30, and the next speaker is Mr. Shishio. That will be at 2:30, so we can go now for the break. Thank you.
Thank you for question.